Good morning, grade 11 students. In this video, we're going to continue our lesson about the karyotype in the genetics chapter. So let's continue about the karyotype. We said the karyotype is an arranged set of chromosomes. So chromosomes, they are arranged according to specific criteria, where the homologous chromosomes, they are arranged as pairs. So imagine that the chromosome is a Twix bar. Twix bar, it has two. So this is the chromosome, it's a homologous chromosome. We have two and two. So two chromosomes, they are homologous. They are arranged as pairs according to the following criteria, according to the decreasing order of their size, according to the position of the centromere, and according to the banding pattern. We said that the chromosomes, they are of two types, either gonosomes or sex chromosomes. They determine the sex of the individual, whether a male or female. Male, it's XY, female, it's XX. And we have the autosomes, they are from chromosome pair number 1 to chromosome number pair number 22, they are the autosomes, while the pair number 23, it's the gonosome or the sex chromosome. Here about the karyotype and the karyotype, this one is for diploid, since we have two copies of each chromosome, so he diploid cell, while it's again عندي only one copy of each chromosome بتكون for a haploid cell, بتكون for gamete, either for a sperm or for an ovum. حكينا عنه last time. حكينا about the chromosomal formula إذا كانت diploid cell 2n equal 46 in the human I said. So 2n equal 46 comma XX if it's a female, or 2n equal 46 comma XY if it's the case of a male, or in the case of haploid 1n equal 23 comma X for a male or a female, but 1n equal 23Y, this is for male exclusively. So chromosomal abnormality, we said they are classified under two criteria, either chromosomal numerical abnormality. This is an abnormality that affects the number of the chromosomes. Either we have an additional chromosome or we have a missing chromosome. So these are classified as chromosomal numerical abnormalities. Today we're going to continue with these chromosomal numerical abnormalities, and also we're going to talk about the structural abnormality that affect the structure. So chromosomal abnormalities that affect the number, they are called chromosomal numerical abnormalities. Maybe there is an extra chromosome, like the case of trisomy, trisomy 21, trisomy 18, trisomy 10, whatever. So trisomy, we have 3 copies of the chromosome instead of having 2. Or we have tetrasomy 4, or the Klinefelter Syndrome, which is the abnormality, or it's called the anomaly, the same meaning, that affect the sex chromosome, where we have XXY, and the individual is going to be sterile, since the abnormality affects the gonosomes and not the autosomes, while if it affects the autosome, it's going to be fertile, so it can give birth. Maybe there is a missing chromosome. We have a missing chromosome, 1 chromosome less, so this is called the monosomy that affects the autosomes, or the Turner syndrome that affects the gonosome, where the female is going to have only X. So this is the karyotype of the individual having trisomy 21. Trisomy 21, we have an additional chromosome. So 2n is going to be plus 1, equal not to 46, equal to 47, since we have 1 additional chromosome, comma, if it's a female, so it's XX. If it's a male, it's XY. Sure, in the question or in the exam or in the applications, trisomy 21, 2n plus 1 equal 47, comma, XX or XY, this one you don't have to do it. Unless you have, for example, ambiguity about the sex of the individual. But if you have a question and you have the sex chromosomes XX, so you only put XX, so there is no need to put XY, and the opposite is true. If it's XY, no need to put XX. Okay, so you have to pay attention to this. And monosomy, so we have a missing chromosome. Missing chromosome, missing means minus, so missing, it's minus 1. So we have 2n minus 1 equal 45, comma, in this case, it's XY. So this is called a monosomy, where it's found at position 7. So it's called monosomy 7, for example. Or if it's 1 chromosome in the 8, it's called monosomy 8. Or 1 chromosome in pair 20, it's called monosomy 20, for example. Okay, so always the number, it refers to the position of the abnormality. And also, you have to be careful about the chromosomal formula. This chromosomal formula, if I ask you about the chromosomal formula, it should be written like this. 2n minus 1 equal to 45 in this case, since we have a missing. If we have an extra, 2n plus 1 equal to 47. And if it's normal, 2n equal 46. Okay, let's continue on to the Klinefelter syndrome. Klinefelter syndrome is the abnormality that affects the gonosome as shown in this figure. So it affects the gonosomes where we have three sex chromosomes. So it will be 2n plus 1 y because we have an additional chromosome. It's equal to 47 also since we have an additional chromosome. XXY, what does this mean? This means that we have three sex chromosomes, X, and X, and Y. So these are problems that affect, that are occurring due to the problems during meiosis mostly. And XXY, if it's a male or female, since we have Y, so it's a male, but it will be male with feminine characteristics, and we are going to talk about it in the coming slides. Here we have Turner syndrome. Turner syndrome. Yes, Mahdi, you have a question before we continue?
أستاذ
Yes, your question, English, please.
عنه جاي يعني.
Uh, it's not like this exactly. It's a male with feminine characteristics, even though it's not it's considered as a gay, no? So it's a male with feminine characteristics. It has some feminine characteristics. We're going to talk about them. And do some properties of a female. That's not a gay. Not necessarily it will be a gay. Okay? So Turner
ماشي.
syndrome, 2n minus 1 equal 45, comma XO. XO meaning that we have it missing in the sex chromosome since we have only X as a sex chromosome. So this is called Turner syndrome. So Turner syndrome, Klinefelter syndrome, they affect the gonosome. Klinefelter syndrome, we have XXY as sex chromosome. So we have an additional chromosome. While Turner syndrome, we have a missing chromosome, so we have only X. So here it's a female with some characteristics. We're going to talk about them later. So chromosomal structural abnormality. Pay attention here. Chromosomal structural. They are abnormality that affects the shape of one of the chromosome more than the other. So it affects one of the shapes of the chromosome. So there is a translocation or a missing part of a chromosome. This can be detected by karyotyping. What's the meaning of translocation or a missing part? For example, if I have chromosome number 21, this is chromosome number 21, and the chromosome number 21, second one, it should be approximately the same. They have the same length. If we have a missing part, what it will be? It will be this is chromosome number 21, for example, and the second one will be like this. So from the karyotype, you can detect there is an abnormality. So here we have a missing part. So here the missing part, it goes. So we have a missing part. It was deleted. Or if it's not deleted or removed, it may be translocated. What's the meaning of this? If I have two chromosomes, this is chromosome number 21, let's say. Okay? So we have a missing part of this chromosome. And in a chromosome 18, we have three copies. So maybe this copy was translocated to another pair, to another position. This is the meaning of translocation, and we will see this in the figure. So this can be detected by the karyotype. So here, abnormality and the chromosomal number. Already we talked about this, autosomal abnormality. Trisomy 21, I'm reading here. So trisomy 21 is called also the familial Down syndrome, which is shown in document A. So Down syndrome, after John Down, the British physician who described the condition in 1866, affected individuals, what do they have? They have three copies of chromosome number 21. They show the following symptoms. They have oblique eyes, they have short hands with unique palm trees, cardiac deformities, and they have mental retardation. Sexual maturity is usually attained. The frequency of occurrence of this disease is 1 in 700 births, but it varies according to many factors and many risks. So a proportion of all is 1 over 700. Another type of trisomy, it can result from the translocation of chromosomes, which is shown in document C. So let's move to document A first. Document A, it showed the karyotype for an individual having trisomy 21. Why? This first of all is for a diploid or a haploid cell. Who can answer me? It's for a diploid or haploid, document A, this document. Yes, Lynn?
Diploid,
Diploid,
since
why?
there's two copies of
Two
each
copies of each
chromosome.
chromosome. Very good. So here, all of them, they exist in copies, in pairs, except for the chromosome pair number 21, where we have three copies of chromosome number 21. So if I ask you for the chromosomal formula, yeah, Muhammad Hassan, chromosomal formula for this karyotype, we have an
Mm.
additional chromosome.
2 and plus 1 equal
Very good.
47.
2n plus 1 equal 47. Very good. So 2n equal plus 1 equal 47. Also, it's over. خلصت.
Uh,
You
says
have, you have to mention the sex chromosomes. Comma. What are the sex chromosomes?
XY.
XY. So very good. So this individual who we made, since it have XY as sex chromosome, and the additional chromosome to n plus 1 equal 47, comma XY. So this is the chromosomal formula. So here we have an additional chromosome, while another type of trisomy 21 can result from translocation of the chromosome. Pay attention here. Here, karyotype with a child with linked or translocated trisomy 21. So they told you, so we have trisomy 21. But if you see all the chromosomes, they are homologous. They are the same, except for 14. Look at 14. This one is larger than the other. So we have a portion of this chromosome was translocated from chromosome number 21. So here they said that we have trisomy 21, but this portion of this chromosome 21 was translocated. It moved to another position. So it moved to chromosome number 14. In the quiz or in the exam or in the question or application, I'm going to tell you that we have trisomy 21. But you have to detect where is the position. So mostly it's here. You have additional. I will give you hints about this. Sure, you're not going to, for example, to focus and go and search. So you have to focus only on the hints, and these hints will help you. So this is called a translocation, where a chromosome was translocated from chromosome number 21, since we have trisomy, to chromosome number 14. So this is called the Robertsonian translocation. So Robertsonian translocation, it's the translocation or the movement of the chromosome from one position to another. So affected individuals, they have symptoms similar to that of the trisomy, like the Down syndrome. However, their karyotype have, in addition to the pair of chromosome, a third chromosome which attached or translocated to another, in this case, to the 14. So other trisomy affecting another pair, if you have trisomy 18, we have trisomy 13, trisomy 8, and so on. So these are the different trisomies found. Let's move here. They said compare the karyotypes of documents A and C. Document A, you have to say about the comparison between these two karyotypes. So karyotype of document A shows 47 chromosomes, where karyotype of document C shows 46. Originally 46, but we have translocation. The sex chromosomes in both karyotypes, they are XY. So both of them, they are males. All the chromosomes, they are homologous in document A and exist in pair, except for the pair number 21, which exists in 3 different copies, and the 3 copies of pair number 21. So an extra copy of chromosome number 21 is found. Whereas document C shows homologous autosomes that exist in pairs homologous. They are the same except for chromosome pair number 14, where one copy is longer than the other. So this was added from chromosome number 21. So this is what do we call it from now on. Whenever we have translocation from chromosome number 21 to chromosome number 14, it's called Robertsonian translocation, which is translocation from a chromosome number 21 to chromosome number 14. This takes place, so 2 separate copies of chromosome number 21 and 1 copy was translocated to chromosome number 14. So this is called the Robertsonian translocation. So always and always, whenever I have to compare between 2 karyotypes, I have to talk about similarities and differences. So both of them, they show homologous chromosomes except for pair number 21 in document C, while homologous chromosomes in document C, we have homologous except for the pair number 14, where one copy is longer than the other. So this is the comparison between these 2 karyotypes. Let's move now to document D. Document B, here we have 2 individuals having the Down syndrome, and part 1, Down syndrome hand in 2 and a normal hand in 3. This is your normal hand. It looks like the one in 3, but the one in document 2, it's responding for one having the Down syndrome. So sex chromosome or gonosome abnormalities Other abnormalities in chromosome number may affect the gonosomes. Already we talked about this. One of them is the Turner syndrome. Turner syndrome is the abnormality that affects the sex chromosome, and mainly Turner syndrome, it affects the woman. Patients have a short stature. They are sterile due to the atrophy of the ovaries. Yeah, they have problems in the ovaries. They have small, very small size ovaries, so they have sterility. Secondary sexual characteristics, they do not develop, so they are not males, females 100%. So they have some characteristics that are near to the man. Okay, while Klinefelter syndrome, these Klinefelter, they are XXY. So Klinefelter syndrome XXY, it affects males who are sterile due to the atrophy of the testes. They have problem in the testes and the development of the testes. So these problems in the testes, they lead to the sterility. They exhibit both male and female secondary sexual characteristics. So these individuals with the Klinefelter syndrome Mahdi, they have abnormal development of the breast, and they have mental retardation. Not all the cases, but often they have mental retardation. Other abnormalities affecting the number of sex chromosome, we have, for example, we have XYY or XXX is very, 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 very rare. So mostly we are going to focus on the Turner syndrome, XO, or the Klinefelter syndrome, XXY. Moving to figure B, talking about the variation of the frequency of the trisomy 21 as a function of the maternal age. So here, let's focus all of you on the graph. This graph is showing the variation of the frequency of the Down syndrome, frequency of the trisomy in percentage as a function of the maternal age in years. As you see here, as the age of the mother increases from 35 to about 43 here, what happens? The frequency of the Down syndrome increases from 0.5 to approximately 2.5 or 3. Okay, so here it increases slightly, while when the age of the mother increases from 43 to about 46, the frequency of the Down syndrome increases sharply to reach about 9, 8 or 9%, 8 to 9%. So this is a sharp increase in the frequency of the Down syndrome. So this means that as the maternal age increases, the frequency of having a child with Down syndrome or Down syndrome or the trisomy will increase, that the chance will increase. So females having the age above 43, they have an increased chance and the high chance and the high risk of having children having the frequency, having the Down syndrome. Then the frequency increased to about 9%. So this percentage is very high. So this frequency is affecting the child. So this child maybe will develop an abnormality. This is related to the aging of the cells, the problems in meiosis, and so on. So all of them, they are affecting the embryo or this child and have a high chance or high risk of having the Turner syndrome or this trisomy. So what can you conclude from document B? Document B, as the maternal age increases, and pay attention here to the colored words. As the maternal age increases from 35 to about 44 or 43, there's no problem about this. So the frequency of the Down syndrome here, it increases what? It increases slightly. So I have to use this. It doesn't increase sharply. From here to here, it increases slightly to about 2.5. From 0.5 here 0.5 to about 2.5 to 3 approximately. While when the maternal age increases from 44 to about 46, we have a sharp increase in the frequency of the Down syndrome, which increases to about 8. So here it increases sharply to about 8%. So what does this indicate? This indicates that the frequency here, I did interpret and then I gave a conclusion. This indicates that indication should be specific for the graph or for the experiment. This indicates that the frequency of Down syndrome is directly proportional to the maternal age. So as the maternal age increases, the frequency of the Down syndrome increases. As the maternal age decreases, it will also decrease. So here, chance of having a child after 43 or 44 for the maternal age, having high risk of having children with trisomy or with the Down syndrome. Conclusion, maternal age, it affects the frequency of the Down syndrome, so increases the chance of having the Down syndrome disease here. So you have to pay attention to this. So the chance is increasing with the increase in the maternal age. Maternal age is the age of the mother. Father doesn't affect a lot, has some causes. We will not focus about them in grade 11. We're going to focus about them in grade 12. Okay, so here about document B. Let's move to these karyotypes. Karyotypes of documents E and F. Document E, it shows a karyotype of a woman having the Turner syndrome. Immediately, whenever you see Turner syndrome, so it affects the gonosomes. Immediately, you have to study this, and you have to be familiar with this. Turner syndrome affects the gonosome. What is the abnormality here? We have abnormality in the sex chromosome, where we have only one X. So if I ask you, yeah, Cynthia, what is the chromosomal formula here? We have Turner syndrome. We have additional or missing?
2 and minus 1 equals 45, comma, x 0.
Protonic minus 1 equal 45. Very good. Comma, XO or X0, whatever you want. It's XO هي mainly. أنا بقول لها X0 كمان تتذكروها إنه there is no chromosome. Very good. Thank you. Thank you, Cynthia. Let's move now to Yusuf. What do you think, Yusuf? The document F shows a karyotype of a male having Klinefelter syndrome. So what do you think, Yusuf? What is the chromosomal formula?
Yusuf, his microphone isn't working.
It's not working.
It
Okay, يلا تعالى. Your turn. Yeah.
Can you
Klinefelter.
repeat the question, please?
Klinefelter syndrome.
Yes.
Okay, so this abnormality affects the gonosome for sure. And if you see this, this is the gonosomal abnormality. So what is the chromosomal formula?
Yes. It's 2n plus 1 equals 47, comma, xxy.
2n plus 1 equals 47. Very good. Since we have an additional chromosome, then we put comma. What are the sex chromosomes? They are X, X, Y. Someone is going to ask me, Mister, how did you know that these are XX? This one is X, and this one is similar to it. So sure, it's going to be X, and the smaller one is going to be Y. In the quiz, I'm going to give you the sex chromosome without giving the letters under them. I will give you like this. So immediately you have to know that these two, they are X's. So XX, and this small one is Y, so it's XXY. So what can you say about the fertility of individual in document E? What can you say about this, yeah, Nada? What can you say about the fertility of individual of document E?
أول وحدة
Document E.
بطلع sterile
Sterile, why?
because it's only X.
It's only X. It's not a complete justification, yeah, Nada. It's only X, it's not a complete justification because this is a gonosomal abnormality and it affects the gonosome, so that's why it's sterile. It has a problem in fertility. Okay, Nada?
Okay.
Okay, moving to document F. Mirna, what do you think, Mirna? Document F, sterile or fertile? Mirna, good morning. Mirna.
أنا ما
Hello.
عنده مايك.
Great, great. Okay, thank you. Moving to Ran. Yalla Ran, what do you think? Has a problem of fertility or normal?
No, مش normal.
Why?
Sterile.
Why?
Because there is a gonosomal abnormality.
And it affects the sex chromosome having XXY. Thank you, Ran. So this is the questions, and idolic questions that maybe they're going to be in the quiz or the exercises and so on. So write the chromosomal formula of the documents presented in documents E and F. Chromosomal formula, document E, it's Turner syndrome. So it's 2n minus 1 equal 45, comma, XO. And the document F, it's Klinefelter syndrome. So it's 2n plus 1 equal to 47, comma, XXY. So these are the chromosomal formulas. Moving to this document, document H. Document H is showing a pair of chromosome 5. Chromosome 5 of a child affected with a syndrome called Cri-du-Chat syndrome. It's called the cat cry syndrome. This syndrome, Cri-du-Chat syndrome, it affects the chromosome number 5. What will happen? This Cri-du-Chat, this is a disease where the baby is going to emit a sound like a cat's mewing. Okay, so Cri-du-Chat disease or the cat cry syndrome causes severe mental retardation, larynx malformation, so the baby emits sounds like cats mewing. The karyotype of affected individuals showing abnormality of one of the copies of the human chromosome 5. You see here, this is the first pair and this is the second pair. Here we have two chromosomes, two copies. Where here the first copy, this is the normal, while the abnormal one, it has a missing part. So part of this chromosome is missed here. So one of the parts, a portion or a segment of the chromosome, it's missed. So this is the cause of the Cri-du-Chat syndrome. So what is the type of mutation shown here? From the comparison, we noted that the abnormal chromosome is shorter than the normal one. So we have deletion or removing of a fragment of the chromosome takes place. So this is the cause of this abnormality. So if I ask you, this abnormality is numerical or it's structural? Yes, sir. Do you want to ask a question or you have to answer? You want to answer?
I want to ask a question.
Yes, you ask your question before we continue.
إنه abnormality that refers to the cats. طب كيف هيدا الabnormality transferred from the cats to the human?
It's not abnormality from the cats. It's referred to as the Cri-du-Chat, similar to the crying of the cat. It's not from the cats, yeah. Okay, so it sound like it makes the sound like the cat's mewing يعني. For example إنه عم بنوه for example بيطلع هيك الصوت قريب. So Cri-du-Chat هي سموها هيك because it's similar to this. مش معناتها جبناها من البسين الكروموسوم يعني. Okay? Okay, so moving to Hani. What do you think, Hani? This chromosomal abnormality, it affects the structure or the number of the chromosome, the Cri-du-Chat syndrome?
The structure.
Structure for sure. ليش؟ لأنه portion or a part of the chromosome was deleted here. So عندي شقفة من chromosome, it was deleted or removed. So here deletion of a fragment of a chromosome. So this is a structural abnormality and it's not a numerical one. So this is everything for our session today. Thank you, guys.